today, we're solving problem 21 from the Spring Amc 10A from 2021. Let A, B, C, D, E, F be an equal angular hexagon. The lines A, B, C, D, and E, F determine a triangle with area 192 root 3, and the lines of B, C, D, E, and F, A determine a triangle with area 324 root 3. The perimeter of hexagon A, B, C, D, E, F can be expressed as m plus n times the square root of p, where m, n, and p are positive integers and p is not divisible by the square of any prime. What is m plus n plus p? So here we have drawn this out, two triangles. We call these segments PQ. The first thing we notice, equal angular hexagon. That means a normal hexagon, equal angles. This has to be 120. That means if all these triangles 60, 60, and 60. So the same logic can be said for all these triangles. All of these are 60 degrees by using that form of logic. So, yeah. Well, now we know that we have a bunch of equilateral triangles, and these two big equilateral triangles are also equilateral triangles. Now let's just look at this triangle that has a segment PQ in it. I don't want to write this other length because that would be too concerning. But this area, well, what are we given that? Okay, the lines A, B, C, D. So these lines is going to be, this area is going to be 192 root 3. Similarly, well, I'm just going to write it like this. Similarly, X, this triangle of XY has an area of 324 root 3. Okay, and we want to find the perimeter. Well, let's just take this triangle of PQ. We want to use the Pythagorean theorem. So let's just do that. Well, it states that we will have, well, we just want to find something here. So, this is an equilateral triangle. When you cut it in half from one point, from the altitude, you split this directly in half with the right angle there. So, this is all PQ. So, let's just do PQ squared, since all the sides are equal. This is going to be 1/2 of PQ squared plus the height squared. I'll just call it H. Now, we get that. We want to find the H, or at least a common thing for the height. So, the height, here, I'll just write it like this. So, PQ squared minus 1/4 PQ squared. Take the square root of that is H, or the height. So what's really in here is, I'm just going to move it around to make it a lot easier. The height is going to be 3/4 times PQ squared. Take the square root of that. Well, now we get that H is equal to root 3 over 2 times PQ. Okay, that is the height. So, using that same logic, there's actually two heights, one for the PQ triangle and one for the XY triangle. So, let's just call this one H, and let's call the other height H1. Now, we know that H1 is equal to, well, 3 root, well, over 2 times PQ. No, not times PQ, but times XY. Because we can still come in from the altitude, cut it in half, and do all that stuff. Okay? You know, okay. Okay, so we have these two heights. We can express them as areas. Let's just take this PQ area. We have this height. We have to multiply it by PQ, then divide by 2. So PQ's area for triangle PQ this is going to be the height times PQ again, that's the base, over 2. So this is going to be root 3 over 4 times PQ squared. This is going to be what? Well, we were given that it is 192 root 3. So, after solving for PQ, we get that PQ is, let's see here, PQ is going to be 16 root 3. Okay. Now the area for the other triangle, which is going to be the area of XY, that area is going to be also the height times XY over 2. So this is also root 3 over 4 times XY squared. Similarly, this is 324 root 3. After solving for XY, we get that XY is 36. So, we want to find the perimeter. How does this help us? Well, think of this as like folding, sort of. This is an equilateral triangle. This is the perimeter. XY is going to be 36. If this segment plus this middle segment is 36, this side is equal to this side, and this side is equal to this side, so that's still going to be 36. Similarly, all these sides is going to be 16 root 3, so the sum is going to be 36 plus 16 plus 3. That's what the question wants. This is going to be our answer, 55, and we are done.